Okay, in this video I'm going to show you guys how to plug in my texture maps from my texturing program into the PxrSurface material for RenderMan in the Hypershade window. In my case, I was using Substance Painter with a output template that is meant for RenderMan and PxrSurface in particular. So this is what the layout is going to look like in the end, and this is what the final look is. So I'm going to kind of show you guys from scratch how to build that. Okay, here's my material with nothing inputted into it, just a default PxrSurface. First thing I did is I went ahead and double clicked this and named it, gave it a name. I might also name the shading group, so wood_SG for shading group. So before we start plugging our textures, let's go ahead and look at what Substance Painter output for us. So I go ahead and find my texture maps. So Substance Painter, when it exports texture maps for RenderMan and PxrSurface, it's generally going to be outputting these 5 texture maps here. They're diffuse, so that's going to be our surface color, our displacement, which is going to be essentially at render time moving our geometry and moving the surface of our model up and down. We have our normal map, which is similar to the displacement map, but what it does is it fakes surface detail by changing the orientation of our surface, or the appearance of the orientation of our surface. So it looks like they're pointing in a different direction and catch light or cast shadow in more detail. So even though this is a pretty continuous surface with not a lot of polygons, you can see that it's going to have a lot of little detail and little cracks and bumps in it. And so it's just essentially, you can think of normal maps and bump maps as fakes, whereas displacement's actually going to move my geometry at render time. We have our specular face color, and so you'll notice with a dielectric like mine that I'm using, this isn't going to change. It's going to be constant across the whole object. So unless you're actually changing material properties, like if you're changing it from a gold to, let's say, a wood or a stone or skin, then generally speaking, you don't really want to have any variation in here, because for a material, like one material, it's more or less consistent across the whole object. This reflectivity, this front-facing specular reflectance value is going to be unchanging for the most part, because it's very much based on the material. Okay, so the last texture map I'm going to have is the specular roughness map. So that's going to be the breakup of my specular reflections. Are they sharp or are they rough? So that's usually going to be one of our most commonly used texture maps, is the specular roughness, the diffuse map, and then the normal map. Sometimes displacement, not always, and not always specular face color. This is for a specular roughness workflow, so just in case anybody came into this video wondering what kind of texturing workflow or shading workflow we're working with, this one is specular roughness. If you don't know what that means, don't worry about that. If you don't know what that means, don't worry about it at this moment. Okay, let's get into plugging those in. So I'm going to come in here, and I am going to press Tab in my Hypershade and search for my Pixar texture node. Press Enter. Okay, so this is going to be my file loader. It's going to load in my texture files. I'm going to rename this one. This is going to be called diffuse_txt for texture. Okay, and I can plug this straight into the diffuse color, right? And it'll look something like this. But first I need to go ahead and make a modification to it. There we go, that looks right. Okay, sorry, I had to clear the buffer and restart the render. So when I plug in this texture map here into this color, you'll see it's pink, which means that I'm missing my texture map. So I have to go ahead and load in that texture file. So I'll go ahead and open that up, and I'll search for my diffuse color map. Don't worry about the naming so much. We'll worry about that more when we get into Substance Painter. This isn't a great naming setup I have here, but we're mostly looking at the name of this attribute, so diffuse color. So it's telling me it wants to go into the diffuse color. This number right here, 0.1001, has to do with its location in the UV maps. So this is what's called UDIM or UDIMs. And again, this is something that we can cover later, but if you're ever curious, that's what that 0.1001 after the attribute name stands for. It's essentially a location marker in my UV coordinate space. So let's go ahead and open it up. Okay, so I went ahead and loaded the texture. Sometimes you'll see it kind of have like a blue color. Let me go ahead and see if I can get that pulled up really quickly. So I had to stop it before I converted it. I just want to show you what this looks like. Sometimes you'll see this gray image and it has like a blue R on it. So this just lets you know that RenderMan and the background is still processing your texture map. So it's not ready yet. It's still loading it in. And so if you open up your texture map, texture maps location, you'll notice if you come down here, I have my diffuse color map, right? So teapot medium Lambert 3 diffuse color, and this is a .png file. If I scroll down here, I have the same file, .png, .tex. So this .tex file format is essentially a converted file format that RenderMan likes to use for its own purposes and calculations. So you don't really have to worry or care about that much. You just have to know that when you load in your texture maps, RenderMan first has to pre-process your texture maps, convert it into a different format for it to read. So keep that in mind, that your texture maps, especially really large texture maps, might not work right away. And also if you're running IPR, it's also going to go slower. Okay, so I loaded in my diffuse color map, and you'll notice, maybe you don't, but it's not quite right. So if I come over back to my materials and I take a look at this, you'll notice those colors don't quite look correct. And that's because by default, I'm working in a linear sRGB color space. I'm not talking about any other color spaces right now, not ACES or Filmic Blender or anything else like that. This is just the default RenderMan linear sRGB. And so if you haven't thought about color spaces before and you don't really know much about them, you shouldn't really have to worry about it. So don't think too much about it. But do understand that RenderMan is rendering in a different color space than what we're used to looking at on our computers. We're used to looking at things on the web or in Photoshop or many other programs in an sRGB color space. And so it's essentially a color space that has a certain particular range of colors that is friendly for our display devices, like my monitor or a gaming console or my phone, right? So those devices that are meant to be displayed for our eyes are using this commonly used color space format. RenderMan likes to render in a linear color space, and so that essentially is going to have a better distribution of color values that makes operations and measurements and physically based, rendering and lighting and stuff like that more predictable and easier to work with. But the problem is that I made this texture map in an sRGB color workspace, and so it's being modified. So the linear color space is changing all the values in my image or my render to linear, and then it's going to change it back to sRGB to view in my like on my monitor, and that's what I'm seeing. So you can see if I come up here, view image color space, we have linear, and if I go down to display view, it says Rec 79, but really it's sRGB. So the rendering color space is linear, and then the display color space is sRGB. Okay, so since I made that map for an sRGB color space, it's not loading in correctly in the linear color space, right? Because it wasn't made for linear color space. So what I need to do is I need to come to this texture map here, and I need to click on this button called Linearize. What that's going to do is it's going to apply a color adjustment so that my texture map is adjusted correctly for the linear color space. So when I click on that, now I can see that looks much closer to what I'm trying to do. So unless you're using ACES or something else like that, if your texture maps are looking a little washed out, then just make sure you guys go ahead and click on Linearize for your diffuse color maps. And so this only applies to any of our colors that we're going to see in the render. Any black and white data maps like a Specular Roughness Map or Displacement Map, do not click Linearize, because those are just data. That's like raw data. Like, this is my roughness value at this particular surface, and I don't want to color manage it. I don't want to change that value, because when I click on Linearize, it's going to adjust my values. Okay, so what I also like to do is I like to make sure I add a remap node, so Pixar remap. I'm not going to go into detail what these texture maps are or manipulating the hypershade, or these nodes are. So if you're confused about any of this or want to know more, make sure you check out my RenderMan nodes tutorial video. I go into more in depth in those. So I just attached a remap node so that I can adjust the values, right? Do I want to make it darker, brighter? Do I want to increase my contrast, or do I want to decrease the contrast? So I'll just set that back to 1. And even though I'm probably not going to use it for this case, I like to have that for that control. And then my HSL is going to let me shift the hue. So if I want to give it like a slight yellow tint, or if I want to push it warmer into the red color, and then I can push the saturation more intense or desaturate it. Okay, so that is the diffuse setup. Okay, let's take a look at the specular roughness. So when I'm usually doing a new material attribute, okay, before I get into that, one thing that is really important to do is to solo and activate just that node and isolate it from the rest of my shading. So that's going to be really helpful for removing like lighting information, like colors from your lights can mess with it, different shading attributes, like if I have a really reflective and shiny surface, that can kind of get into the way. So even though I have this right here, if I solo that texture map, it's going to get rid of all that other information and only show me that texture map by itself. And then it can also show me different nodes, right? So that texture map, but being remapped, right? So if I use that remap node to brighten my texture map, if I look at just a texture map, it's going to show me the unmodified texture map. And if I click on that remap node, it's going to show me that texture map now remapped. And let's go ahead and set that back to 0.5. So just something to keep in mind. All right, so let's go ahead and load in a new, I'm going to reset that. Okay, we'll load in a new texture map. So what I'm going to do is I'm actually going to take this Pixar remap right here, and I'm going to go ahead and edit. I could just, take this and duplicate it. I can drop in a new one by adding a new node. But I'm going to go ahead and duplicate this remap node. So I'm going to go duplicate shading network. What it's going to do is it's going to take that node and the node that's connected to it and duplicate them with the connections intact. And so if I did that from the HSL, it'd duplicate the remap and the diffuse or the Pixar texture, and they'd keep them connected. Okay, so this one I'm going to call this one the rough._txt. This is let's go ahead and find and load in that texture map. So specular roughness. So we have to keep in mind that when I open this up, this is a black and white texture map. Let's go ahead and plug it into specular roughness. So nothing's going to change yet, and we'll take a look at that in a second. But if I open this up, I don't want to linearize it. And that's because this is a data map. These values are pure like material attribute values. In this case, they're representing the roughness value of my surface. They're not meant to be colors to be displayed. So if they're not going to be colors to be displayed, just make sure you're going to not click this linearize button. So most of your texture maps, you don't want to linearize. Your color map that you're going to show, you do want to linearize. Okay. So we'll go ahead and click that. It's not doing anything. Why is that? And that's because we don't have our specular active. The colors are set to black. So I'm going to go ahead, and I'm using artistic mode. I could use physical mode. I'll set this to a low dielectric specular face color value. So let's say about 3%. So somewhere between 2 to 5%. Maybe we'll set that to 0.025, so 2.5%. And then the edge color, we want to be white. Okay. So yeah, that looks pretty good. I'd say maybe it's a little too glossy, a little too shiny. A lot of times what I'll do is I'll disconnect my other texture maps so I can take a look at my the texture map I'm currently modifying or trying to plug in and see if it looks correct. So I could look at that in isolation. So I might say like maybe that's a little too glossy, right? So I might raise the overall mid tones of my roughness map to be a little bit rougher. So now the overall texture is a little bit rougher. And that looks good to me. I'm not going to go crazy on it. And I'll plug that back to my diffuse map. Okay, next up is going to be, let's look at what we have left. We did our diffuse color, we did our roughness. Let's go ahead and do our normal map. So I'm going to go ahead and I could load it in through the Pixar texture, but there's also a node called the Pixar normal map node. So the Pixar normal map node is going to load in a texture and treat it as if it is a normal map, because the normal map has to be kind of interpreted differently than our color or data maps. So I'll click on that. And so let's just go ahead and look at this, and plugging what we want to do to attach it is you want to attach that result normal into my bump normal. I didn't kind of talk about this because I talk about it more in the hypershade video, but we're outputting or taking the output of our red, green, blue color channels and putting it into our color inputs. And anything that is expecting a single value, so like these green nodes, which mean they accept a single float value, I'm taking a single color channel and plugging it in there. Okay, but in this case, we're taking bump normal information. So I'm going to take this normal output and plug it into my bump normal. And you can see already that it's having an effect. It's really subtle, but it's actually wrong. It might be kind of hard to tell at first. So let's go ahead and I'm going to disconnect my texture maps, my other texture maps, and just look at the bump map and maybe make this slightly rougher so we can see that a little bit better. So it might be kind of hard to see, but the word hello is supposed to be cut into the surface, it's pushing into the surface. So this part that's raised should be catching a light on the top right here because the light's coming from above, right? But it's dark on top and light on bottom, so that's somehow backwards. So this normal map, if you don't have the correct orientation on your normal map, you can come into this normal map node and you can flip the orientation. If you're in Substance Painter or any other program that is, you're setting up your project and you're defining what the normal orientation is, then if you're going to be in RenderMan eventually, you want to go ahead and set that to OpenGL. You'll see that when you set your project configuration in Substance Painter, it's going to ask you, it should be OpenGL or DirectX. So you just want to use OpenGL. If you don't, in my case I didn't, I do have to make a orientation modification here. So what this is going to do is my normal map is going to have direction information, right? So the red, green, and blue channels are going to represent different directions that the surface is going to be oriented towards. So if it's more green, right, it's going to point in a particular normal direction. It's more blue, it's going to point in a different direction. If it's more red, it's going to point in another one. Because of that orientation, whereas like in Substance Painter, that red was saying, let's say, pointing to the right, in this case, it thinks red is pointing to the left. So I have to flip these values so that it's telling it, no, 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 you're supposed to be pointing the other direction. So that's kind of the easiest way I can kind of, make that really quickly. And we can also set the custom or the open or the orientation as well. So in my case, I think maybe I must have set it up as OpenGL. Okay, so maybe I just had to set it as OpenGL. I'll show you guys anyways. Here's what it would look like with DirectX. It's pretty subtle. Let me go ahead and make a snapshot of this so you guys can see. Let's go back to OpenGL. And so it's a very moderate difference. Like it's very, very subtle and very hard to tell. So that's why I recommend you guys disable the other texture maps. But you can see with the DirectX, actually, I think the DirectX is correct. Okay, yeah, actually the DirectX is fine because the lighting is coming from the right? And so this is a cavity, so this is a raised wall and lip. So these walls are getting hit by the light, so that looks correct. And then these walls are casting shadows, which is correct. So with this one, it's the opposite, right? It almost looks like it's pushing out of the surface right here. And what I said earlier about this being OpenGL is correct, right? Oh wait, so this is direct. Okay, sorry, I confused myself. Okay, so I set it to OpenGL, which is correct. DirectX is incorrect. But if I had custom and I didn't know what I was doing, I can always, again, come in here with all my other texture maps disconnected and try flipping the orientation of these. And you can see the flip X is pretty similar to, or pretty much exactly what the OpenGL is doing. So if you know what your orientation is, just go ahead and set it here. If you don't, just take a look at this without your other texture maps plugged in and see what it looks like. You'll see if I go ahead and flip the Y, it's pretty interesting, but it almost looks like it's actually popping out of the surface. So instead of being pushed into the surface, it's actually pushing out. So let's go ahead and switch that back. This scale value up here is going to be essentially the intensity of my bump map or my normal map. So I can kind of reduce the effect by playing with that scale. So I can bring it down. Now it's really subtle. I'll set it back to 1. I'm not going to go into the specifics of most of these nodes. What I will mention here is that in the newer versions of RenderMan, there is now a new node called the PxrBumpMixer, PxrBumpMixer. And you'll notice too that there's our result normals and there's also our surface gradient normals. So you don't have to know specifically what that means. I mean, I barely know what that means. It's pretty technical, but it's a new way of interpreting bump and normal maps and bump and normal information that's more efficient and in some cases more accurate. So it also comes with this node that is really great for layering and combining different bump and normal maps together in a way that was hard to do before. So especially if you're working with a bump map, which is scalar or black and white, and then you also want to add a normal map on top of it, which is going to be color information, so vector information. they don't really play well together, right? Imagine taking in Photoshop a black and white image and a red, green, blue image and then combining together. They don't quite work together in a way you'd predict. But this PxrBumpMixer knows how to interpret all of those inputs and combine them together. And so you have this layering function where you can add them together, you can subtract from each other, you can do an over operation, you can mask them out, you can dial in each layer. It's great. It's very very powerful tool. So any of these nodes that have this ng, they want to, if you're using this PxrBumpMixer, you need to take an ng output here, and you take that result normal here. And let's just go ahead and take a snapshot. It's going to look pretty much exactly the same if I set this up correctly. So let's go ahead and take a look at this here. The one thing is that it's going to handle the orientation for me, so I can unclick that. And let's actually, I think so. Let's set that to OpenGL. Okay, I clearly am messing something up here. Let's set that to custom. And let me just fix that really quickly. Okay, there we go. So this is definitely outside of my expertise. I haven't used this node very much, but you can see here, it looks exactly the same as when I just plugged it in. I just had to modify the orientation if I'm using this Pixar normal map. So yeah, but you can see here, it looks exactly the same. It's just a different setup, and I would recommend this if you're bringing in multiple texture maps, multiple bump and normal maps, and you want to layer or add them together, or you want to convert like a procedural node. Let's go ahead and try that really quickly. Here we go. So I just created this really quick noise node, and I just loaded it as another layer. And as long as it has that surface gradient output, I can plug it in here. If you plug anything else in there, it kind of doesn't give predictable results. But you see it's just adding this layer on top of the other one. So it's combining them, merging them together, and this is what that node looks like, right? And here's what our normal map node looks like. So it's just an option, is if you want to layer multiple bump and normal information together to make a more complex texture map here. But for simplicity's sake, I'm just going to go ahead and plug the output normal from my Pixar normal map node and plug it into my bump normal and just make sure my orientation looks correct. So I can do that, or I can just set that to OpenGL. Okay, the last texture map I'm going to set up here is going to be my displacement. So in order to set up my displacement, I'm actually going to go ahead and disconnect everything else. So displacement is actually going to be a separate shader. So we have our PxrSurface shader, and then we're actually going to add a displacement shader. You can even see here, surface shader and displacement shader. So what I'm going to do is I can go ahead and press tab and type in Pixar displace. Okay, I can do that. And it's going to drop that here, and it creates a new shading group for it. I'm going to delete those for a second. Or I can just select this shading group node for my main material and type in Pixar displace, and it's going to go ahead and connect that for me. If for any reason I need to connect it manually or it doesn't do it for me, I can click on the shading group node. You'll see it has a RenderMan surface, which is where my main material is plugged in, and RenderMan displacement. And I can middle mouse click and drag that, I let go. Middle mouse click and drag onto my RenderMan displacement. You'll see it automatically connects for me. And it's going to connect the out color into RMan displacement, if you guys ever need to know that. Okay. So for this, I'm going to load in my texture map for it. So Pixar texture. We're going to go ahead and call this one disp_txc for displacement texture. Okay. And I'm going to go ahead and search and find it. So I'm going to come here to displacement, click open. All right. And so I could just plug this into my displacement node. There's two types of displacement, just like bump and normal maps. There's scalar and vector. Scalar is going to be black and white. Vector is going to be color. And so a black and white map just essentially means the surface either pushes up or pushes down into the surface. So white means off the surface, black means push into the surface. Vector map is essentially going to use red, green, and blue to determine direction. So push up and to the left and back a little bit, right? So it has more definition, more information, more accuracy, a vector displacement map will. But most, like nowadays, most of the displacement maps we create are going to be scalar, at least for the meantime. That might change later. So if I wanted to plug my black and white texture map, my displacement map, and that's this one right here, into my Pixar displacement node, I would just grab one of the color channels because it's black and white, doesn't matter which one I grab, and plug it into displacement scaler. You'll see right away that is not right. That is definitely a problem. And so that is just because two things. First is by default, the intensity for my displacement is way too high. So the default of 1 for this gain value right here is super, super high. This is different though if you use a program like ZBrush that can export displacement maps that are scaled appropriately to the size of your object. So you can have certain programs that create displacement maps actually look at your model, look at its scale, look at its geometry, and create a texture map that is appropriately scaled to it. But generally speaking, like if you're exporting from Substance Painter, it's not going to do that for you, at least not in the current version I have. So usually we set this to low value, like 0.02 or 0.01. Let's do 0.015. Maybe let's do 0.02. Let's raise it up a little bit. Let's do 0.04, I guess. All right, and so you can start to see a little bit of that effect. One thing, it doesn't feel like it's quite right, and I might try just starting IPR. Sometimes that helps. Nope, okay, that's not it. Okay, so I think this value is too low for it. So that's something you have to keep in mind is, I make sure I disconnect everything else. We're just kind of get a sense of if this looks correct or incorrect. So in this case, I felt like maybe this is too low, so I might use a different value, so 0.1. Generally speaking, I do want to scale it down quite a bit, but yeah, so I just want to kind of see that surface detail, kind of similar to my normal map, right, which looks kind of like that. But you'll notice here with my displacement, this is definitely not right? Why is it all of a sudden inflating like it is, been stung by a bumblebee, right? And that's because if I take a look at that texture map, it is basing whether it's pushing the surface up or pushing the surface in on those pixel values. By default, it is treating black as the flat surface, like don't push in, don't push up on the surface. So any black pixels, it reads as, hey, don't move the surface. Anything brighter than black, it pushes up. Anything lower than black, so negative values, pushes down into the surface. In this case, this is what Substance Painter gave me, and this is clearly all much lighter than black. And so clearly, Substance Painter thinks the height map or displacement map should look differently, right? And this is pretty common amongst displacement maps, is you're going to have, this is what's called like a gray centered or 50% centered displacement map. And what this does is it's actually treating 50% gray. If I color select here on like a gray value, right, we're going to get in the 50% range right here. 50% is going to be about, I think 128, is that it? 128, right? So pixel value is 128, so that's perfectly 50% between 0 and 100%. So that is what this texture map thinks is the flat surface, is 50% gray. But clearly, RenderMan thinks that's not true, which is why we're getting that goofy looking inflating teapot. Just to kind of further show this, let's go ahead and bring up a Pixar blend node. This is just going to output raw color values. So my top color is what's being output. It's black, 0. If I can do RGB, right, all the pixel values are 0. And if I plug that in here, and if I compare that to when I didn't have the displacement map plugged in, you see the surface or the silhouette isn't changing at all, right? So you can see it hasn't moved, which means that that's what my mid value is, the value that is treated as a flat surface. So as you can see, as I increase this, my object, oh yeah, I have the right one. Okay, my object is going to start inflating, right? It's going to get bigger and bigger and bigger, right? As these values get higher, it's going to push the surface up more. So let's set this back to black. Okay, so my texture map has about like 50% gray. So what we need to do is we need to use a node in between here called Pixar Disp Transform. So this is going to transform my displacement values. So now I'm going to go ahead and plug one of my color channels into the displacement scaler of this node and take the result float value. So it's a single scalar value. You would use XYZ if you're using vector. So result float value, and plug that into the Pixar displace scalar value or input. So nothing's changed, but here we have a couple settings, right? So I can change what type of displacement I'm using. I can set the max and min, or essentially a multiplier for the max and min values. So pushing in, I can make it push in less, but keep the push out higher, or vice versa. But more importantly, right here is this remapping mode. And so right now it's set to none, which means black is the flat surface. But if I set this to centered, what it's going to do is it's going to treat my 50% gray values now as a center. So let me go ahead and see if I can get this started rendering again. There we go. All right, so it clearly looks wrong, and that's because I'm plugging in black. And now it thinks 50% gray is the center, so anything darker than 50% gray is now pushing in. So since this is black, it's like crunching my entire model in. You'll see as I raise this up a little bit brighter, right, it's going to get less and less crunched in, or kind of contracted, right? And then as I get closer to 50% gray, it goes back to normal. And then when I go higher than 50% gray, it starts inflating again. So let's just go ahead and set that to 0.5, 0.5, 0.5. Okay. And so now this is essentially 0.5, 50% gray is now the mid surface value. Don't move the surface at this value. Cool. Which is great for this texture map because this is mostly 50% gray. So if you export your texture map texture maps from Substance Painter, this is what you're going to want to do. You don't have to go into Photoshop and measure the values. You just have to know that you want to do centered and set that displacement center to 0.5. Okay, so let's go ahead and plug that texture maps output into there now. Okay, now we're getting that information, but without this surface kind of distorting and wobbling and inflating, right? And it looks very similar to the bump map, right? It just has like a little bit of actual depth information to it. So it has, whereas this is kind of fake, and at a certain point, we didn't reach it quite here with this texture map. At a certain point, normal maps and bump maps can start to look really kind of not believable. They don't hold up. This does because it's actually pushing the geometry in render time, so we're actually casting shadows and getting accurate lighting calculations. But it's a little too strong, so I would come in here and I maybe say like 0.05. Let's maybe say 0.07. I think that's pretty good. Okay, and then if I compare that to what it looks like with a bump map, that looks pretty good. One of the main differences, and this it's so subtle that we can't tell on this model, but the main difference you'll see is that the surface is actually changing. With a normal map, right, the surface, no matter how much I increase the normal map value, the silhouette of the object actually isn't changing. So the appearance of the surface, like the shading on it's different, but the model's not actually moving. The geometry is not moving. So with the displacement map, it is. So you'll see this together, right? My displacement map, it's set up pretty good, right? Just remember, we want our remap node, a remap center at 0.5. We want our gain set to a low number, and we want to not linearize our texture map, right? Because it's a black and white data map. So you might wonder why use my bump map and displacement map. They're doing pretty much the same thing. And in a lot of cases, they kind of do, and you don't need both of them, right? And maybe in this case, I might just use the displacement map. But usually what people do is, for VFX, right, is if the surface detail, the changes, like these little bumps and ridges are small, like these are, then the bump map is totally great. It's cheaper, it's light, it's efficient, it's easy to use, it's a fake, right? But you can't tell, right? But any big surface changes, like maybe these letters, require a displacement map there. Anything that's a really big surface change that we're going to notice is kind of faked by the normal map, we might want to use a displacement map for. And this is all VFX related, animation related. If you're doing games, you probably wouldn't use displacement maps. You would just use normal maps because they're way cheaper than displacement. Displacement is very rendering heavy compared to normal maps. So a lot of times what people do in VFX and animation is they'll reserve the big details for their displacement map. So the displacement map will have some different details than the normal map, and the normal map will have finer details. And then they combine them together so that together they get all the detail they want, but the displacement's not trying to carry all the weight and do everything for you. That's if you export out of like Substance Painter and you're not controlling what's going into a normal map and what's going into a displacement map, is generally going to put both of the information of the big surface details and the small surface details in the exact both of those maps at the same time. So just keep that in mind. But in this workflow, what I like to do is I like to use displacement and then use my normal map to just accentuate the edges and the details. So let me go ahead and snapshot this. And let's go ahead and bring the image. So this is the normal map. Here's a displacement map. And here I'm going to go ahead and plug the normal map into the bump normal. Okay. Oh, and let's bring that one down. This is the right one. And so you can see this is way too crunchy, right? Because it's doubling up on all that surface information. The displacement's doing it and the normal map. So here I'm going to actually dial back the normal map a bit. And I might dial back in the normal map, and I might dial back the displacement a little bit. So let's say 0.05. Okay. So here's the displacement. Here's the displacement with a little bump, and you can kind of see it's starting to get a little bit of extra sharpness to it, right? I can kind of push that a little bit higher, so like maybe 0.55. So yeah, we're getting a little bit crisper edges from that normal map. That normal map really helps bring kind of the detail, especially in some of these small surfaces right here, back. So it's pretty common that people use a normal map and displacement map in conjunction with each other. So here's just normal map by itself. Oh, I hate that. Here's displacement map, and here's normal plus displacement. And here's normal plus displacement compared to the normal map. Something that you can kind of do that's pretty cool in render, or the render viewer here, is you can select a layer, set it as the background right here. Choose a different layer that you want to compare it to. Click on this little wipe tool right here. And what I can do is I can wipe across the screen and kind of compare whatever the background is to my current layer. Cool. Yeah, so I can see that extra detail. And it's probably a little too much, but we'll leave it for now. So I'm going to turn off that background thing, so disable that. Okay. So that's my displacement layer combined with my normal map. Let's go ahead and plug in my specular roughness map so we can get the reflection breakup, which adds a ton of detail already, and then my diffuse map. Cool. And so that's all those texture maps plugged in. Those are the 4 of the 5 most common texture maps. We'll look at the 5th in a second when we look at metals. Okay, here is a metal setup. And so let's go ahead and take a look at those texture maps. So we'll go back. Let's go to my gold pattern. So I have those 5 texture maps I highlighted earlier from Substance Painter. We have our diffuse color, displacement, normal map, specular roughness, and then specular face color. So a reminder is on that face color, or the color and intensity of my reflections, for the wood, that was just a flat blank gray value, right? So it's just constant across the whole surface. And if this was just pure gold and nothing else, it would also be a constant value, right? It would just be, where is it? It would just be that gold color right there. But in this material, I'm actually changing from like a gold foil into like a black or, like a hard plastic kind of lines that are holding it in. So we have these lines in between that are like a dielectric or a plastic, which have dark, desaturated, low intensity reflections, specular face color. And then my gold foil, which is metallic, is going to have these really saturated and bright specular reflections. Ooh, there's a lot of detail here. So that's just now, since I have actual variation in here, I'd actually want to plug in that texture map. So here's my setup. I collapsed some of these just to make it a little bit simpler, and it's a simpler setup. I didn't put like my HSL and my remap nodes in here, even though I should. So I have my diffuse map, right? And so remember, with a metal, you want to turn off diffuse, right? Because you want it to be just purely specular reflection. So anywhere where there's metal, you'll notice that the diffuse map is black. Remember, we want to linearize it, right? And so here's my specular color, my specular face color. Let's take a look at that. Here's what it looks like. I linearized it too. This is what it looked like when it came in, which obviously does not look correct. Looks a little too bright. And because this is this color that I'm actually going to be looking at in the renderer or viewer, I want to linearize it. So your diffuse map and your specular face color map, make sure you linearize them. Again, unless you're using ACES, then that's a whole other situation. And then we have our roughness map. Our normal map, I have a slightly different setup where I'm actually taking a texture map and plugging it into a Pixar normal map node. We have our displacement map and our final render result. Cool. So that's pretty much it. I'm going to go ahead and show you guys one last thing, which is how to kind of mix these together with other inputs or other images. I'm going to do that on the wood material. Okay, here I have my texture map, right, with its Pixar texture, going to remap node, going to the HSL node for adjusting the hue saturation levels. And I actually wanted to combine it with another input. In this case, I'm using a procedural noise, and I'll show you another texture map in a second. So I just made this noise really quickly. I used the manifold 3D, plugged into it the noises manifold so that I can scale it. And then what I did was I plugged this noise into a Pixar threshold, which essentially lets me clamp my values. And I can change that threshold to change where it clamps it off and cuts off my pixel values and sets them to white or black. And you'll notice you can use something like this with the Voronoi or fractal noise, and a higher threshold, you're going to get kind of like these splotches, like almost like dirt or paint splotches, right? And let's make this a little bit scaled up a bit. Let's do something like that. There we go. So these are larger splotches. So what I'm doing is I'm using a blend node. So the blend node's the best way to combine two color or image inputs and blend them together or mask them together. In this case, let's get rid of that. Okay. In this case, I have my color map, and I want to have this like kind of yellowy, not yellowy, this kind of like brown, yellowy, I keep saying yellow, this light brown color that is kind of my splotch color, my paint splotchy color that's going to be on top. And so I'm using this as a mask. So let's go ahead and disconnect it, and you'll see what this looks like. So this blend node, it's with the normal operation, whatever this top color is, or this top input, if it's an image, it's just going to sit on top of the bottom input. If I bring this top alpha down, this is going to turn on and off that top layer. So I bring it down to 0, now top layer is not visible. If I bring it up to 1, it's 100% visible. So I'm going to use this input or output up here as a mask for that top layer. So now, wherever it's white in this texture map, right, it's going to turn on that top layer down here. And where it's black, it's going to show the bottom layer. So that's one way I could do it. Here I went ahead and brought in a mask. So I exported a mask from Substance Painter. So let's go to Wood. So I have this little hello mask. And so I just exported a black and white image that masked out the text. So I could go ahead and do the same concept here, where I just take one of my color channels and plug it into the top alpha. And now it's masking off that, whatchamacallit? It's masking off that that text layer, and then only showing this color here wherever it's masking off at. And I could do that with layered materials, right? So I can do this to, instead of doing the blend node, I can turn on and off like a particular material with a Pixar layered surface. If this blend node, right now I'm using these inputs as masks. I could also just use them actually as the color, right? So right now it's just showing only the top layer, right? Because again, this top alpha is 100%. If I bring that down, now I'm showing the bottom image. And I can combine the top layer and bottom image together if I know about blending operations or blending modes. So if you don't know what those are, feel free to look it up on YouTube. Photoshop is always a great example. The philosophy is the same across these programs. Sometimes they have slightly different names, but blending modes or blending operations is just a way of combining two images that are stacked on top of each other in a particular way. So in this case, normal just means that whatever's on top is just covering the bottom. You can't see the bottom at all. If I did, let's say, screen, right? What it's going to do is it's going to take the light pixels and combine those with the bottom pixels and then get rid of all the dark pixels. Or multiply, it's going to do the opposite. It's going to take all of the, where is it? Multiply. It's going to take all of the dark pixels and combine them with the bottom image and leave all the light pixels alone. And so there's all kinds of different setups here, right? And with a black and white image, you're not going to get a whole lot of variation to this that you can mess with. If I plugged in just like this normal map, or this Voronoi map, let's go ahead and set this to 3 and plug that into the top alpha. We can get much more interesting kind of variations because it has gray values. It's not just black and white. But like I mentioned before, I'm not going to go into specifics of how this works. I just kind of wanted to show you guys that would be how you could combine multiple texture inputs together to plug into one. Okay, I want to go over two more things. First, I'm going to open up this texture manager. I talked about it very briefly before about when I'm loading in a texture for the first time, RenderMan has to convert the texture into a format that works for it. This a tool right here called the text manager or texture manager. It's this little TX right here. When I click on this, it's going to show me all of my RenderMan textures that are being used by RenderMan here. And if there's a green check mark by it, what that means is that the texture has been converted. If you ever, let's say, update a texture in your file path, so let's say wherever you're storing your textures, you replace them with updated textures, RenderMan doesn't always know that you've updated your textures and might not reconvert them for you. So what you would want to do in that case, you'd click on Parse Scene. And if you see them with like a little kind of progress bar and they're not green check marks, that tells you that it's in the middle of converting it. And down here, it also tells you how many of your textures are finished converting. Right now, I have 20 out of 20. So just keep that in mind. I'll take a look. What we're going to take a look at next is some ACES related stuff. So if you're not using ACES, don't worry about it for the next component. But I did want to kind of mention this texture manager in case you're using an ACES workflow. Everything I've been talking about up to now has been for the linear sRGB workflow, which is default in RenderMan and default of what you guys are using, unless you guys purposely change it. Okay, I've gone ahead and switched over to ACEScg. The main difference here is that I don't really have to worry about linearizing, right? So I can unlinearize. It really isn't going to have an effect on my texture maps. It's not going to look at that setting. So you don't have to worry about linearizing if you're using ACES in particular. But we do have to worry about how it's reading in our texture maps. So before, this texture manager is not actually converting my textures or adding a modification to them. But once I switch over to ACES, it's now going to take my texture maps in here, and it's also going to load or convert them to using a different color management kind of system. So let's go ahead and find that diffuse color. So this is this one right here. Let's go ahead and parse my scene. And I'm going to go ahead and I might have to reset it 1 second. Let me see. I think it's the workspace texture diffuse. Let's see. Here it is. So you see right here, it has no color space transformation. So just like how you have to turn on Linearize for linear sRGB, if you're using ACES, you have to come in here and change that color space to sRGB texture. That's telling it's an sRGB texture that needs to be converted. So I click on that and click apply. If you're loading in this texture by default with ACES already set up, you don't have to do this. It'll automatically try to figure it out for you. It's a little dark, so I'd have to take a look at that and adjust that. I didn't make my textures for ACES, so there's going to be some discontinuity there. But I click on here, diffuse. Oh, that's the leather, my bad. Here it is. So now you can see that's sRGB texture. So since I've already done this in linear sRGB and it's already kind of set up, it's not converting it. But yeah, when you start this for the first time, what's going to happen is, let's go ahead and actually try that for the first time. I'm going to reset these textures. Okay, I went ahead and reconverted my textures. So essentially kind of set it up as if I hadn't started linear sRGB and just opened my file in ACES and imported my textures. So you'll notice by default, it's just going to go ahead and convert to the color space that it thinks it's correct. It takes your texture map, it takes either the type of texture map it is, file format, or the naming convention, and tries to choose what it thinks is best. Like, oh, this is probably a color map. Let me do sRGB. So you'll see with my normal map, it's loading in as data. So anything that's not color, right, it should be data. So that's good. Diffuse map, read as sRGB texture. That's good, right? We want sRGB texture if it's a color map. Specular roughness should be data. That's good too. Displacement is sRGB texture. I'm not sure exactly why this happens, but it tends to like do this with displacement maps, maybe because of file format, I'm not sure, or maybe there's a reason why it's sRGB texture, but it should be data, just like my specular map and everything else. This is height data. This is data of the surface moving up and down. So I'd go ahead and set that to data. And so you have to double check your textures. You have to come in here and make sure it's setting the right color space conversion for that texture map. It doesn't always get it right. It's going to make its best guess, so keep that in mind. There are naming conventions you could use out of Substance Painter that will go ahead and guarantee that RenderMan is always going to know what that texture map is supposed to be, but just keep that in mind. And then the last color space that you'd have to worry about would be, where is it? Let me go ahead and make sure I can find it. 1 second. Here we go. So if you have an HDRI map, it tends to want to do it in sRGB linear. So color maps, including specular face color map, right? So for my metals, I would want my metal color map, the reflection colors, to also be sRGB texture. So diffuse color should be sRGB texture. Specular face color should be sRGB texture. Everything else should be data map. And then my HDRI, whatever's plugged in my dome map, should be sRGB linear. So just keep that in mind. You guys need to double check this and make sure everything's correct in the texture manager if you're using ACES or any other OCIO or color management workflows.